For decades, we all thought the peak of air combat was about three things: going faster, turning tighter, and most importantly, being invisible. Well, guess what? The rulebook's been completely torn up. The new king of the sky, it's not a pilot, it's not even a plane, it's something you can't even see. It's data. Just let that sink in for a moment. I mean, we're talking about a massive shift in military thinking here. The very idea that these multi-billion-dollar jets, built for one reason and one reason only, to be ghosts in the sky, are suddenly vulnerable? That changes everything we thought we knew. So that's the real puzzle, right? How do you see the invisible? I mean, if radar can't pick it up, and you definitely can't see it with your own eyes, how are you supposed to target a ghost? Well, the answer isn't down here on the ground. You have to look up. Way, way up. That's right, we're going into orbit, because that's where the new high ground is. And I'm not talking about hills or mountains anymore. Forget missiles, forget lasers for a second. The ultimate weapon in this new arena is just being able to see. Okay, so picture this. Hundreds and hundreds of satellites. They're up there, forming this silent, interconnected web that blankets the entire globe. And this isn't your old school spy satellite that just flies over once a day. No, this is a constant, persistent grid. It's like a single, perfect eye in the sky that never, ever blinks. And here's where things get really, really interesting. This whole network makes a new kind of fighting possible. It's called asymmetric warfare. Basically, it means you don't have to be a superpower with a fleet of billion-dollar stealth jets anymore. All you need is access to the data that can see those jets. It completely flips the script on who has the power. And this idea of borrowing the eyes of a global giant, man, that just nails it. Think about it. A smaller country with a pretty basic arsenal. They're not on their own anymore. By plugging into this orbital network, their weapons can be guided with insane precision. They're literally borrowing the eyesight of a superpower. All right, so we get what's doing the watching. But the big question is how? How does this all-seeing eye actually see? How does a simple stream of data from space turn into a weapon that can take out a plane that was literally designed to be untouchable? And this is the technical nut to crack, right? Stealth planes are built to be like black holes for radar. They're covered in materials that just soak up radar waves or bounce them away. So if you can't see it with your main tool, how do you track it? Well, it turns out you look for the one thing, the one tiny thing, it can't hide. And the answer? It's almost beautiful in its simplicity. It's just basic physics. You can't move through the air, especially not at supersonic speeds, without leaving a mark. No matter how sleek or advanced a plane is, it has to push air out of its way. And that friction, it's like a fingerprint in the sky. So what we're talking about is this faint, invisible wake the plane leaves behind. A tiny thermal signature. To you and me, it's nothing. But to this network of super sensitive sensors up in space, which are constantly crunching just immense amounts of data, that faint little trail isn't just a clue. It's a dead giveaway. The plane's location, its speed, its direction, it all becomes a simple math problem. And this is how it all plays out. It's like a perfectly rehearsed deadly dance. First, the sensors up in orbit detect that friction signature. Then, in the blink of an eye, an AI analyzes the data. But here, and this is the real game changer, the AI doesn't just see where the plane is. It predicts where the plane is going to be. Finally, a missile is launched, and its path is constantly tweaked and updated from orbit. The pilot can try to dodge and weave all they want, but it's like trying to outrun your own shadow. So let's just put this side by side. The old way, with radar, it's like shouting in a dark room. You send out this loud ping that basically announces where you are, and it can be jammed, it only sees in a straight line, and it's always playing catch-up. The new way, it's completely silent. It's passive. It's watching everything from above. And the crucial part, it's not reacting, it's predicting. But wait a second. This whole system relies on a constant digital handshake between the satellite and the weapon, right? That sounds like a pretty big weakness. I mean, if your enemy can jam that signal, or even worse, hijack it, the entire system just collapses. So how do you make that connection unhackable? Well, the answer sounds like something out of science fiction. It's called quantum locking. The best way to think about it is like this. Imagine you're trying to tune into a radio station, but the frequency is changing millions of times a second in a totally random, unpredictable pattern that only you and the satellite know. That's pretty much it. The data stream is locked in this constantly shifting quantum state.
If anyone else tries to listen in, the whole signal just collapses. It's an unbreakable code.
Okay, so let's pull back and look at the big picture here. What does all this mean for the future? We're seeing a massive fundamental shift. It's no longer about who has the biggest, baddest planes or ships. The real power, it's in the invisible flow of data that tells all that hardware what to do. And this creates a whole new set of rules for war. Rule number 1, the high ground isn't a hill anymore, it's the network. 2, the incredible skill and reflexes of a human pilot, they're basically canceled out by an AI that already knows what you're going to do before you do. The human in the loop is reduced to just watching the math play out. And in this new world, having the data, it isn't just an advantage, it's everything. And that right there is the key takeaway. Think of all the money, all the years, all the brain power that went into creating the perfect stealth plane. And it can all be made useless, not by a faster, better plane, but just by a smarter flow of data. It's incredible. So where does that leave us? When you have this constant, all-seeing eye in the sky that can see things designed to be invisible, how many blind spots are left? How many places are there left to hide? The answer is simple: 0. The very idea of a blind spot, which is the whole point of stealth, just evaporates. And that leaves us with one last, kind of chilling question to chew on. When the sky itself is basically woven from data, who controls the weather? In a world where it's not about who has the most planes, but who controls the network, who is really in charge?